What if the world as we know doesn't start exactly the way we know? The Big Bang Theory is a scientific explanation of how the universe began. It states that the universe originated approximately 13.8 billion years ago from an extremely hot, dense, and singular point, which rapidly expanded and continues to expand today. This theory is supported by evidence such as the cosmic microwave background radiation, the observed redshift of galaxies, and the abundance of light elements like hydrogen and helium. The Big Bang Theory was first proposed by a Belgian physicist and Catholic priest, Georges Lemaitre, in 1927. He described the concept of the primeval atom or cosmic egg, suggesting that the universe had expanded from a single, initial point. Lemaitre's idea was not purely a product of imagination, it was based on observations and mathematical reasoning. He built upon Albert Einstein's general theory of relativity and combined it with evidence from astronomy, such as the expansion of the universe observed by Edwin Hubble. Hubble's discovery that galaxies are moving away from each other provided strong support for Lemaitre's idea. While Lemaitre introduced the concept, the term Big Bang was later coined by Fred Hoyle during a radio broadcast in 1949, ironically as a dismissive term for the theory he disagreed with. Over time, evidence from various scientific fields confirmed the validity of the theory, making it the leading explanation of the universe's origins. Imagine standing beneath a clear night sky, looking up at countless stars scattered across the heavens. Have you ever wondered where it all began? The story of our universe is one of the most fascinating mysteries science has ever unraveled, and at its heart lies the Big Bang Theory, a bold explanation of how everything we see, and even what we can't see, came to exist. The journey begins over 13.8 billion years ago, in a moment of unimaginable density and heat. Scientists believe the entire universe was once compressed into an infinitely small, incredibly hot, and dense point known as a singularity. Then, in an instant, this singularity began to expand, not like an explosion, but like a balloon inflating. Space itself stretched, and in doing so, it carried with it the seeds of galaxies, stars, and planets that would eventually form. This is the essence of the Big Bang Theory. The universe didn't just start, it started to grow. This idea didn't come out of nowhere. In the 1920s, Georges Lemaitre, a Belgian physicist and priest, first proposed that the universe was expanding. His idea was later supported by Edwin Hubble, who observed that galaxies are moving away from us, with their light shifting to the red end of the spectrum, a phenomenon called redshift. This discovery was like finding footprints leading back to the universe's beginning. But that's not the only evidence. In the 1960s, scientists discovered a faint glow of microwave radiation spread uniformly across the sky, now known as the cosmic microwave background radiation. This relic of heat is like an afterglow of the Big Bang, a snapshot of the universe when it was just 380,000 years old. And let's not forget the abundance of hydrogen and helium, the simplest elements, whose proportions align perfectly with what the Big Bang Theory predicts. As the universe expanded and cooled, particles combined to form atoms, and gravity began pulling matter together to create stars and galaxies. Over billions of years, these stars fused elements in their cores, ultimately producing the heavier elements that make up you, me, and everything around us. Yes, the iron in your blood and the calcium in your bones were forged in the heart of ancient stars. The Big Bang Theory isn't without its mysteries. What came before the Big Bang? What's causing the universe to expand faster today, something we call dark energy? And what is dark matter, the invisible glue that holds galaxies together? These unanswered questions remind us that science is a never-ending journey of discovery. So why does the Big Bang Theory matter? It's not just about understanding the past, it's about appreciating our place in a vast and dynamic universe. Every star we see, every galaxy we explore, and even the atoms in our bodies are part of a story that began billions of years ago. The Big Bang Theory gives us a glimpse into that story, igniting curiosity and inviting us to keep asking, what's next? Now the question of what was before the Big Bang is one of the most profound and puzzling topics in science. And while there is no definitive answer, several theories offer intriguing possibilities. Some scientists argue that the concept of before may not apply since time and space themselves began with the Big Bang, much like asking what's north of the North Pole. Others suggest that quantum fluctuations in a pre-existing quantum state could have sparked the Big Bang, potentially within a vast multiverse where countless universes form and exist. Another possibility is a cyclic universe, where infinite cycles of expansion and contraction create repeated rebirths of the cosmos. Theories of eternal inflation propose that our universe is just one bubble in a continuously inflating larger cosmos, while brane cosmology, rooted in string theory, suggests that the Big Bang resulted from the collision of multidimensional surfaces, branes, in higher dimensional space. Philosophical and theological perspectives add further depth, pondering creation and the limits of human comprehension. Ultimately, the laws of physics as we know them break down at the singularity, leaving the question open until we develop a theory that unifies quantum mechanics and general relativity. Despite the uncertainties, exploring this profound question continues to expand our understanding of the universe and inspire human curiosity. While the Big Bang theory is widely accepted, it's not without its critics and alternative perspectives. Some skeptics argue that the theory raises more questions than it answers. How can something emerge from nothing? They question the plausibility of a singularity containing all the universe's energy and mass, expanding into the cosmos we see today. Others point out that the idea of an initial explosion, even if rebranded as expansion, seems to defy the laws of thermodynamics, particularly the principle of conservation of energy. Philosophers and some scientists suggest that the Big Bang is a convenient narrative but fails to address the deeper why of existence, why a singularity existed at all. Proponents of alternative theories, like the steady-state theory, challenge the Big Bang's reliance on unobservable phenomena like dark matter and dark energy, arguing that these are speculative constructs meant to patch up gaps in the model. Even the concept of cosmic microwave background radiation, hailed as proof of the Big Bang, is criticized by some for having explanations within other frameworks, such as plasma cosmology. For these dissenters, the Big Bang may not be the definitive answer, but merely a stepping stone toward an even deeper truth waiting to be uncovered. If the Big Bang marks the beginning of time and space as we know it, could there be aspects of reality, dimensions, forces, or phenomena beyond our understanding that existed before and continue to influence the universe today? Finally, if you enjoyed this boring scientific thing, hit the like button, subscribe for more and turn on notifications so you never miss an upload.